All right. Today we are talking about selection sort. Similar to the bubble sort video, I'm going to start off with the very general idea of selection sort, and then we'll look at a little bit more of how you go about programming selection sort. I'm still not going to show you any code, just like with my bubble sort video, but it should be very easy if you know the basics of how to manipulate an array, or if you're going to do this with a list, then how you manipulate a list. So things like adding a node to the list, removing a node from a list, traversing the list, things like that. So yeah, let's get started here with the very general idea of selection sort. So selection sort, just like bubble sort, is very simple idea for how you go about doing it. So we start off with, well, let's say, first of all, we're trying to sort this list of things from smallest to biggest. So smallest on the left and biggest on the right. So what we want to do is we want to look through all of our items and find the smallest item. You could also do this by finding the biggest item, but it's the same idea, but we're going to go with the smallest item. We're going to say this one is the smallest item. And what we're going to do is we're just going to essentially move it to its own list over here. We're going to separate it from these other ones. And then we're going to go back and say, okay, now what's the smallest of the remaining items? I'm going to say, okay, it's this one. So we're going to move that one over here after the smallest one. Then we're going to keep doing that again. So we're going to say, all right, of these remaining ones, which one is the smallest? So it's this one. So we move it down here, and we just keep doing that. So the next smallest one is going to be this one, and then the next smallest one is going to be this one, the next smallest one is going to be this one, and then the next smallest one is going to be this one. And that's all there is to selection sort. Very simple. Now let's look at, Now let's look at how do we actually do this in a linked list. If you are not familiar with linked lists, you're familiar with arrays, you'll want to skip ahead to that section. So with a linked list, we've got all our nodes that are pointing to each other. I've got a doubly linked list here. If you are using a singly linked list, you can still do selection sort. It's just a little bit more of a pain because you have to remove nodes, which means you have to keep a reference to the previous node. So we're going to do it with the doubly linked list. It's a little bit less of a hassle. So the reason I'm going for the linked list approach here before we go to the array method is a linked list corresponds to the general idea a little bit more easily. So we are going to have some kind of pointer or reference that is going to traverse through the list, and we're going to look for that smallest node. So we're going to start here and we're going to say, okay, this one's the smallest. We're going to go to the next one. And we're going to say, is this smaller than that one? And we're going to say, yes, 2 is now the smallest node. And then we're going to go to the next one here, and we're going to say, okay, is this 1 smaller than the minimum, which is 2? And we're going to say yes, so we're going to update the minimum again. And we're going to keep traversing. Is 7 smaller than 1? No. Is 3 smaller than 1? No. Is 6 smaller than 1? No. Is 4 smaller than 1? No. And we get to the end here, and we say, okay, so this one is the smallest node, and we are going to remove that from this list and essentially start a separate list. And we are doing this just by changing the pointers of the node. The node isn't actually like moving in memory or anything, but just to clarify the visuals here a bit, I decided to, we're just moving these nodes, whereas in reality you would actually just change these arrows. But to keep things looking clean on the screen here, we're just gonna move the nodes so that these arrows like still point nicely to each other. All right, so that is our first iteration through there. So min is actually still pointing to this 1 at this point. And then we're going to need to keep track of the tail of this new list that we're making down here. But we need to keep going through this list. Let me actually just move all this up real quick so that we have a little bit more space. So we need to traverse through the list again, and we're going to keep doing that until this list is empty. So we're going to start here again. The min is the first one, and we're going to traverse this, and we're going to say, okay, is 2 less than 5? Yes, it is. So we're going to update the min. Is 7 less than 2? No. Is 3 less than 2? No. Is 6 less than 2? No. Is 4 less than 2? No. So now we have the min for our second iteration through the list. So we're going to remove that. Sorry, this would have gone off the end. So now we can fix our visuals here. And then we're going to update the tail. And then we're going to go through the list again. So we're just going to keep doing that. I'm going to try to go a little bit faster here. Less talking, because otherwise the more I talk, the longer it's going to take. So we're going to get to the 3 is less than 5. And we're going to move these down. Connect that on there. This is now the tail of our new list. And I guess I never really explained the tail, but we're keeping track of the tail of this new list so that we can add a node onto the end of it very quickly instead of having to start at the head of the list and traverse to the end of the list to add a new node to it. All right. So let's finish doing this. No, no, no. Yes, that one's smaller. Move that down. Go back here. Sorry. Update this first. Let me come back here. No, no. Move that. Update the tail. Let me say, yes, this one's smaller. Oh, sorry. Update these again. And that was the last one. So now this list is empty. And this is the new sorted list. So that's the list approach to selection sort. Like I said, very, very similar to the general approach, which is why I went with this one first. But now let's look at arrays. So selection sort with an array is kind of a slightly different idea because we are stuck. We're not really stuck with it, but what we want to do is we don't want to create a new array to move numbers into. We want to do this all within the same array. So what we're going to do is we're going to find the smallest node, and we want to move that to the front of the array. Let me move some things here. So we're going to have a variable. I'm just going to call it slot. This is going to keep track of what node we are moving the smallest node into. So the first one's going to go to this first box. And then we're going to traverse the array with our green arrow. I'm just calling this I. So that's going to refer to these boxes. And then, so we're going to start off with the min here. And we're going to update the min every time we're looking at a box that is smaller than the current min. So 2 was less than 5, so we updated the min. 1 is less than 2, so we are updating the min. 7 is not less than 1, so we leave the min alone. 3 is not less than 1, so we're leaving the min alone. 6 is not less than 1, so we're leaving the min alone. And 4 is not less than 1, so we're leaving the min alone. So we traversed the array once. We have the min here. And we know it needs to go into this first slot. So there's 2 ways to do this. One is to swap these. But this is not stable, so we'll talk about that later. But that is the non-stable approach. It's very fast to do it that way. Well, I mean, overall selection sort is not a fast algorithm. But that is significantly faster than bubble sort. But it's not stable, like I said. So if you want the stable method, you move this out of here, and then all the items that are between the slot and the min, you need to shift them over. So we shift this way, shift this way, and then we put this in here. So that preserves the order of these other nodes, which is what allows that method to be a stable sorting algorithm. So it's up to you which one you use. I'm just gonna stick with the stable version for the rest of this here. So we got the first one in there. We can now update our slot to the next one and then traverse again. Sorry. So, but first of all, let's just mentally check this off. We are never going to do anything with this slot again. It has the exact number we want. So each subsequent iteration through the array is going to be shorter than the last one. That's similar to bubble sort, how bubble sort put the biggest one at the end and we never needed to mess with it again. In this case, we have the smallest one at the front. We never need to mess with it again. So our next iteration through the array, we're gonna set the min to the first one, and then we're gonna move on. Is 2 less than 5? Yes, we are updating the min. And then we're gonna go through the rest of these, and we're gonna see that they are all bigger than the min, so we never updated the min again. And so we're gonna pull that out of there, shift this one over, and we are done with that second iteration. So we can move that over. We can check this off again and do our third iteration. So set our min again to the first one that we're looking at, and then keep going. And this time we're going to see 3 is less than 5, so that's the new min. And then we keep going. And then we are going to pull that one out, shift these ones over, and put the min in its slot. And that third iteration is complete. And then we go again. Set our variables up. 7 less than 5, no, no, yes. Update the min. And then put the min in its place by pulling it out, shift them down. And almost done. You can see the shifting makes this take significantly longer if we have to do a lot of shifting than if we just do the swap. All right. There. The min is still 5. We don't essentially have to move the 5. So that's done. And then this last iteration here, well, yeah, we're gonna say, okay, it's now the min. So put this over, put this in here, check that off. And then at this point, we just go to the end and be like, oh, there's nothing left to do. And that one is done. So that's the array method of selection sort. Like I said, that is the stable version of doing it. Maybe I'll just go through the whole thing real quick with the non-stable method. So let me reset all our stuff here. Oh, actually our numbers are out of order, so I gotta move those too. All right. Take a second. 5, 2, 1, 7, 3, 6, 4. All right. So I'm just going to do this without talking. But yeah, we're just going to be swapping. We're just going to be swapping these instead of doing the shifting. That one's done. And that one doesn't get moved because it's already in its slot. And there, and then we update the min. Swap them. There, update the min. Update the min again. Swap them. Nothing needs to get moved because the min's already in its slot. And again, nothing needs to get moved. The min's already in slot. And again, we are done. That's the unstable version. Like I said, the unstable version does the swapping, which can mess with the order of things. So, yeah. Sometimes you need the stable version, sometimes you don't. But either way, selection sort is not very fast. So you're probably not really going to use it in experience. Or in reality. In practice. That's the word I'm looking for. Alright, so we'll just talk about space complexity real quick. Selection sort, just like bubble sort, is a constant space complexity, big O of 1. You need a few variables to keep track of things as you move them around, but it does not change with the size of the input array or list. For time complexity of selection sort, it is also big O of n squared, just like bubble sort, because you are going through the entire array multiple times, basically. And even though, or array or list, and even though it gets shorter each time, it's still the total number of things that you're doing is proportional to the length squared. This does not change whether or not you are doing the stable version of selection sort for an array. If you're doing the stable version or the unstable version will be faster, but it's still proportional to the length squared. I don't know exactly how much faster. I think it'll be like ballpark, like maybe 30% faster or something. Like, not a ton faster, not like orders of magnitude faster, but definitely faster. And then, is selection sort stable? The list version of selection sort is stable as long as you make sure you, when you're going through finding the smallest element, you want the first instance of that smallest value when you're pulling out the smallest one and building the list that way. And then for the array, like I said, there is a stable and an unstable version of selection sort. So we've got an example real quick here. So in the input, we have the green 4 is to the left of the purple 4. And if we do the stable version of selection sort, we pull out the 1 here, and then we shift these down on the first iteration. The second iteration, they're both 4, so this will be the min and it doesn't get moved. And the third iteration, nothing happens, it's the last element. Whereas if we look at the unstable version of selection sort, we would swap the 1 and the green 4, and now the green 4 is to the right of the purple 4, whereas originally it was to the left of the purple 4. So that's just the quick example of the stable versus the unstable version of selection sort on an array. So that's it for selection sort. Like I said in the previous video, there's several sorting algorithms you should know. Obviously, bubble sort, I already made a video on. There's selection sort, there's insertion sort. Those are all very simple. There's another one called quick sort, which is a little bit more difficult, and merge sort is also a little bit difficult. And there's also one called counting sort, which is actually one I forgot to mention in the previous video, but counting sort is a very, very important algorithm for optimization. You can't use it all the time. It's a very different from all the other sorting algorithms. But when you can use it, it is very fast. So I'm not sure what order I'm going to make all these videos in exactly, but probably going to be insertion sort next.